All right, so this is the final lesson that you have for your course. It's hard to believe that we're pretty well to the end. There are a couple pieces that we haven't really done in depth, but we're going to look at those ones again next semester. So this just gave you a quick kind of introduction to some algebra, a little tiny bit, just enough to get you started in January. So hopefully we've got those gears working a little bit, so you can do some of the calculations going backwards from area to say radius or to a width. And then in next semester, we'll kind of build on that. We'll work with a little bit more of it. We're going to come back to doing some calculations that involve area in more specific trade scenarios rather than just general context. So by the end of this lesson, we're going to have been calculated the area of a triangle. We're going to have calculated the area of a square or rectangle, as well as a circle. And we'll also, I think we're going to look at a trapezoid. I'm pretty sure I put a trapezoid in. For all that I've started it a couple times, I always stop short of getting to the point where the trapezoid should come out. So I think I left it in. I don't think I got rid of it. All right, so first of all, what is area? So we covered volume already, and volume, we covered perimeter already, and perimeter can be drawn with a single straight line. So it's the outline around a shape. When we're talking about area, we're really talking about the fill. So the space that fills an area inside of a perimeter, it's always going to be two-dimensional. So we're going to be multiplying two measurements together. For radius, it looks a little different multiplying two measurements together. When we get down to a circle, we have radius squared, the same as radius times radius. So that's really two measurements multiplied together. That's what gives us two dimensions. Now, one of the things to remember, because area is in two dimensions, there will be a squared after each of the units. So you're going to see centimeters squared. This two, we got two dimensions, meter squared, millimeter squared, inches squared, feet squared. It's always going to be square units when we're thinking of area. So this is a question that's a perfect example of a type of question you could have. This is a question that I commonly like to ask on a test. It's a really good way of getting you to think about conversions with area. How many square inches are in 1 square foot of space? This question doesn't ask you to calculate area specifically. The word area isn't in the question, but we know it's area because we see square inches. So that's a key word to watch for. Again, we have square feet here, so that means we're talking about area. So watching for those key words will help you out. How many square inches are in 1 square foot of space? Well, let's draw 1 square foot of space. If you had 1 square foot, here's 1 square foot. 1 square foot is 1 foot by 1 foot. Well, we want to know that equals how many, oops, that's not a very good square. Let's try and make our square square. I'm going to erase that here. We'll see if I can add in. Here we go. They should be the same size, but I just want to leave a little bit more space for writing. So we want to know, well, how many inches squared would be inside of that? Well, let's think. All we have to do is really a simple conversion. How many inches are in a foot? 12. And if it's 1 foot in this direction, it must be a foot in the other direction. So 12 inches by 12 inches. The area of a rectangular shape or a square is length times width. So we're going to do 12 times 12 equals 144 inches squared. So we could write ourselves a new conversion. 1 foot square is equal to 144 inches squared. So all we're doing is we're just using our formula for a rectangle and thinking about, well, if it was a rectangle, how would I calculate it? Let's do another one of these ones because it'll help us if I ask you for conversions later. How many square centimeters are in a square meter? So let's just do a little quick sketch. So if you have 1 square meter, 1 times 1 is how we would get that. So we have 1 meter by 1 meter. That's what 1 square meter means. Well, let's turn that into centimeters. We want to know how many centimeters. So we'll do 100 centimeters times 100 centimeters. So area is equal to 100 times 100, which gives us 10,000 centimeters squared. So 1 meter squared equals 10,000 centimeters squared. Now you know how to make a squared conversion for area, and I don't have to give you any new formula sheets. You can easily calculate it. If I wanted to know how many square centimeters are in a square inch, well, you have to think 1 inch by 1 inch is your square. Convert the two measurements to centimeters and simply multiply them together. It's actually pretty easy, and I find this helps us kind of visualize it. Now, another way to do a conversion is just to change all of your units right at the beginning, just like I've done. All right, now let's do a question that doesn't make us do conversions right at the beginning. I shouldn't say it doesn't make us do conversions at the beginning. It kind of does. So how many square feet, so that means area, of floor space does a rectangular pallet take that measures 60 inches by 48 inches? So the first thing I always do is I always draw a picture. I find it really helpful. The picture's not given. So this pallet is 60 inches by 48 inches. Drawing the picture makes it easy to pick out which formula. Now, you'll notice it's asking for square feet and we have inches. It's going to be easier for us if we want the answer to be feet. We need to put feet in the formula. We need to put feet and feet in order to get feet out as the answer. So let's convert it. 60 inches is equal to, well, we're going to divide it by 12. That leaves us with 5 feet. And 48 divided by 12 leaves us with 4 feet. Okay, simple calculations. So now that we have that, area is equal to length times width. Length of this is 5 feet times the width of 4 feet. Gives us 5 times 4 is 20. We used feet to calculate, so we get feet out at the end. So we'll put a little note here. Convert to desired units. To desired final unit at the start. That's a really good tip to remember, is to convert your units at the beginning. People who don't will often just divide by 12 once at the end, and they kind of forget that we had to divide the length by 12 and the width by 12, so that works out to dividing by 12 twice. So people will often make mistakes. So our answer is 20 square feet. Better put my squareds in there, those things matter. So the area it takes is 20 square feet. All right, simple calculation, not too complicated, pretty easy to do. Back to this picture. You had to know this one was coming because the last video I made the mistake of telling you square feet. So this question asks us to determine the area of the following shape in square inches given the following measurements. So the measurements are the same as we saw before. We have H is 1 foot, B is 8 inches, T is 2 inches, and that's it for measurements. So when we have a shape like this is a complex shape, but you can tell it's related to rectangles even without my heading because it's like two rectangles stacked together. So these are easy shapes to do. You just divide it into 2 sections. So I'm going to just divide it here. And now we have 2 rectangles. I'll call this one area 1. We'll call this one area 2. So area 1. It's a rectangle, so it's going to be length times width. So the length, we have 8 inches, and this is 2 inches, height of 2 inches. So it's going to be 8 inches times 2 inches, which gives us 16. Extra letter in there, 16 inches squared. All right, now let's calculate the second area because these 2 areas get combined. So area 2, so we're going to calculate this top part. Well, I need to know how long is this side If you remember from before, over here we have 12 inches because this is 12 inches. In order to figure out this height, I'm going to take 12 inches and subtract 2 inches from it because there's 2 inches over on this corner. That means that is a 10-inch height. We still have 2 inches up here because we're told the width of this section is t. So over here we have 10 inches by 2 inches, which gives us 20 inches. Adding them together. The sum of A1 plus A2, we simply add them together and we get 36 inches squared. So nice, easy calculation to figure out our area. So we're just using our length and our width 2 or 3 times in order to do the calculation. So break your shape apart into 2 sections and put them back together. We're going to just do a couple of really simple combined shapes, something like 2 rectangles that you could break into 2 pieces. We'll leave more complex shapes with multiple shapes squished together until our second semester. So what about the area of triangles? So the area of triangles is quite easy to figure out. One of the ways to remember the formula for the area of a triangle is to think about how do you make a triangle out of a rectangle. If we cut a rectangle in half, we get a triangle. Every triangle could be put together. If you take 2 triangles, so if we took 2 triangles like this one, we could put that together. We'd have to cut it in a couple places, but we could put it together in order to make us a rectangle. So the formula for a rectangle area is still length times width, or base times, we call it base times height. So the bottom times the height straight up divided by 2, because it's only half of a square. So that's where the formula comes from. You'll have a formula sheet, so you'll see the formula for the area of a rectangle is written here. Now, what is the base and what is the height? The base of a triangle is we'll call it the bottom edge. I'm going to call it the bottom edge here. It could rotate. It doesn't necessarily have to be along the bottom, but the height has to be measured straight up at 90 degrees to it. So that means we call it perpendicular. We have to have 90 degrees here, so they have to be exactly like a T. You can't use 22 as the height because we have an angle here. It's not straight up. Hopefully that makes sense to you. We haven't really done angles too much yet, but we'll look at some triangle questions later. That comes up in our second term for some courses, not all courses. Automotive gets a freebie on triangles. They get to skip that section. There's not a lot of triangles in cars, but there's lots of circles and cylinders. So now that we have that, we have our base as a measurement on the bottom. This 17.8 is the height of our triangle. It's measured straight up from the bottom. So that's what this little note down here is about. So in order to calculate our area, the area is equal to, it says to do the area in square meters. So we have to do a couple conversions here. So 17.8 is 0.178 meters. And this one is 0.298 meters. So just doing the conversion at the beginning. So there's 1 meter equals 100 centimeters. That's something that hopefully you have that kind of locked in your head at this point. You will get a conversion sheet for your final test. So now if you want to find your area, we're going to do base times height. So 0.298 times 0.178, divide all of that by 2. And we get an area, put that in your calculator, of 0.00265 meters squared. So the trickiest part of this one was convert first. Now, if you forgot to convert first, you made a conversion back on one of the earlier slides that you could have used in order to convert from square meters to square centimeters. But if you just waited till the end and divided by 100, it wouldn't work for you. You'd have to switch it to square centimeters and square meters. So convert first, it's going to be much easier. Now the next triangle does not have any conversion in it. We want meters and it's given to you in meters. The base is still this bottom edge, 6 meters. This is our base, but our height is measured straight up from the base to the highest point. So that's this dashed line here. We don't include that measurement in perimeter, but we do include this measurement. This is our height when we're calculating area. These two are extra pieces of information. We do not need to have them to calculate. So if you want to calculate the area is base times height. So 6 times 8 divided by 2, which is 48 divided by 2, or area is equal to 24 meters squared. Fairly simple calculations for us to figure out. I did throw a trapezoid in. So a trapezoid kind of looks like two triangles stuck on the end of rectangles. But the best way to calculate the area of a trapezoid is to use the trapezoid formula. It's much more complicated to try split it into triangles and rectangles. Sometimes you don't have enough information. So what we do is we use this formula here. So the area of a trapezoid is big B plus little b, so the long base plus the short base times the height. So the bases are these edges that run parallel to each other. One side's long and one side short, and the height is the distance between the two of them. We don't care about the measurement of the two slopey sides. I know that's very technical terminology, the slopey sides, but you'll probably remember it. So we don't need the 7 centimeters that we had on those edges. If we want a perimeter, we would, but we don't need them for area. That's extra information. So all we need to do is put our information in our formula. So the area is equal to the large base plus the small base of 10 divided by 2. So basically what we're doing is averaging them times the height, which is 8. 20 plus 10 is 30 divided by 2 times 8 gives me 15 times 8, which gives us a grand total of 120 centimeters squared. But if you look back, I wasn't a very good person, because I said find the area in square inches, and oops, we forgot to convert first. So what do you do when you forget to convert first? We have square centimeters and we need to find out square inches. How do we do that? Well, I need to know 1 square inch equals how many centimeters squared, and then we could convert it really easy. Well, let's figure it out. So let's say we have a square, it's 1 inch by 1 inch, 1 square inch. We know 1 inch equals 2.54 centimeters. So if this is a square inch, it's 2.54 times 2.54 centimeters. So we're going to end up multiplying the two of those together. So 2.54 times 2.54 gives us 6.45 centimeters squared. Hopefully that wasn't too confusing for you. So I'm just taking my 1 inch. So this was 1 inch by 1 inch, and I'm substituting in, instead of using the inch, I'm using the equal number of centimeters, which is just your number in your conversion chart, and you multiply it by itself. So now that we know 1 square inch equals 6.45 centimeters squared, we can say, well, 120 centimeters squared times 1 inch over 6.45 centimeters squared. Centimeters squared cancels out, so it's 120 divided by 6.45 gives us 18 point, oh dear, I rounded part way here. Let me figure out the number for us. So 120 divided by 6.45, 18.605, and it's a long decimal. If none of these have decimals in them, so I think for square inches, we can go with 1 decimal place. We'll go with 1 extra decimal. So we'll say 18.6 square inches. It would have been easier if I maybe converted at the beginning, but you need to see how you convert at the end. So to convert at the end, this piece here, all of this stuff is how to make a conversion. Okay, so to make a conversion, you find your number on your chart, draw a square, and multiply it by itself twice. If you're not sure about that, go back to the very first slide and look at how I made the conversion on the very first slide. We drew a picture and we used our conversion number from our chart. Hopefully that's pretty good for you. You will not have very many of those, but that would be an absolutely fantastic bonus question, is to ask you to make a conversion for something like square inches into square centimeters. A really good question to throw at you, just as a reminder. All right, circles. So we've already looked at circles in terms of perimeter, so we've learned our circle terminology. As a reminder, radius is the distance from the center to the outside edge. Diameter goes all the way across. All right. Now the formula that we use for the area of a circle, you cannot use diameter even if you want to. You have to use radius, mandatory. So for circles, you must know the radius. But if you remember, the radius is half the diameter. So if we know the diameter, we can easily calculate the radius. So let's start with calculating this question. A circular area with a diameter of 8 inches needs a fiberglass patch. What is the area of the area that needs a repair in square inches? So I've kept it easy, no conversions to do, because sometimes circle stuff gets people confused. So to do a circle, we just said we need to know the radius. So we know diameter equals 8 inches. So radius must be equal to 4 inches. We just take 8 divided by 2, half of it. This is the number that we're going to use going forward. So if I want to know the area is equal to pi r squared. We have already learned that pi equals 3.1416 times 4 squared. Order of operations come into play now. Times 4 squared would be 16. We have to do the squared first, and now we can multiply these two together. And if we multiply those two together, we get 50.3 inches squared. Now, if you were buying a patch kit, it would be important to know, does the kit cover the area that you need to patch? I don't know what you might be doing a patch for, but sometimes those are things that happen to come into play. Let's do another circle question, and then we'll do one that's slightly more complex just for the sake of doing something different. The area of a circle is 1.2 square inches. What's the radius and the diameter of the circle? So this time I've told you what the area is inside of the circle, and we want to know, well, how big is the diameter? This is not a very complicated question, and I think I meant to change a number here, and I'm going to edit that now. Instead of using 1.2, we'll use 2.5, just to make the calculations a little easier for you. You'll see why when we get towards the end. I'm just not going to start recording again because I've started this at least 3 times, and I'm just about through. So when we want to find the area of a circle, we find our formula. So area is equal to pi r squared. Well, I know 2.5 is my area. That's equal to pi. Actually, let's put the number in for pi. You could just write if you just write the symbol pi, you'd never have to write 3.14, but I'm just writing it in for those who might struggle in remembering what pi represents. So 3.1416, that's our pi, times radius squared. Now we need to find out what the radius is. We don't know that. That's what we're looking for. The question says, what is the radius? So we want to find r. Remember from before, it's pi times radius. So to undo that, we go back to our algebra. We're going to divide by 3.14. Those cancel out. 2.5 divided by 3.14 gives us 0.796 equals our radius squared. Now, do you remember how to undo a squared? It's all right if you don't. The opposite of a square is a square root. Now, a lot of calculators put the squared button and the square root button right next to each other, or you just press shift and your squared button in order to undo a square root. So look for your square root button. Your square root button on your calculator is the one, you would have used it back at the beginning, it's the one that looks like that. So look for your square root button. What we need to do is we need to do the square root on both sides. Now, when we take a square root of r squared, it leaves us with just r. And then we take the square root of the number. It's going to give us a decimal. And the square root of 0.796 is 0.89. Now, radius is not an area. Since radius is not an area, it's going to be inches. It's a linear measurement. It's measured with a straight line. It's only in one dimension. If I want to know diameter, it's radius doubled. So 2 times the radius, which is 2 times 0.89. 2 times 0.89, which gives us 1.8 inches for our diameter. Okay, so not overly complicated. You'll have a few practice questions to do that get you just thinking about a few of those things. And this question is just a really good combination question. This shape is technically a trapezoid, but I actually want you to think about it like two different shapes together. So here we have, so you can double check. If you don't believe me that it could be considered a trapezoid, try the trapezoid formula with it. Okay, but I want you to think of this as two shapes. Area 1 is a rectangle, area 2 is a triangle. And we just want to figure out, well, what is the area? We want to know the area in meters, so we don't have to convert anything. So area 1 is length times width, which is equal to 12.5 times 13.4. Multiplying those two together, we get 167.5 meters squared. Because it was meters times meters, we can check back at what the numbers were that we put in. Area 2 is a triangle. A triangle is base times height divided by 2. Well, our base is 10. The height is the same as the measurement we have over here, times 12.5 divided by 2, and that gives us 62.5 meters squared. The total area is equal to area 1 plus area 2, which is equal to 230 meters squared. So pretty easy calculation. Sometimes you could end up, if there's a hole in a picture, you might subtract a circle. There's a few different ways you can do it, but just kind of thinking about breaking shapes up. With area and volume, with area questions, there's a million kinds of questions I could ask you. So you'll kind of have to think about them because we can't do every type of example, but we can give you kind of a brief overview for some of them. When we're thinking about geometry questions. And as you go out to OJT and as you prep for writing your final test for me, I really like this quote. Sometimes the questions are complicated, but the answers are simple. Make it simple. Okay? The question might seem complicated. You are probably making it more complicated than it needs to be. Or maybe I've chosen words that complicate it for you. Ask if you don't understand, but always take a minute to stop and think, what is the simplest way we could do this question? Sometimes it means walking away from it for a minute or going ahead to the next question, but try to make things simple. One of the ways to simplify, before you calculate, make sure you're using a single unit. That single unit will help make things less complicated. The unit you should use is the unit you want for the answer. Which is the second one? Convert before you calculate. Conversions with area suck. They're easy, but they suck. So convert before you calculate. And if it looks complex and you can't think of what it is, try to find simple shapes. Okay? There's always going to be simple shapes. I could give you something that looks like this. It's a rectangle and a half a circle. You can find a circle. If you know how to get a full circle, you could get a half a circle, and I know you could get a rectangle. So you could see a shape like that. Break it down, make it simple. So keep it as simple as possible. Don't overthink it, and you should be just fine. And that will finish off our math review for Math Essentials. And then next semester, we're going to get slightly more complex, and hopefully we'll have you brushed up on all the good skills that you need to have to do block exams really well and to finish everything you need to finish in your trade.